Number 6, the first step, since it is a dividing rational expressions problem, is to find the reciprocal of the second rational expression. So which means I need to flip the second fraction. So the first one stays the same, x squared minus 2x minus 3 over 2x plus 1. I'm going to change the division to a multiplication, and then I'm going to have 2x squared minus 3x minus 2 over x squared minus 4x minus 5. Once it is flipped or found the reciprocal, it is just like the problem before this on number 5. I'm going to factor each fraction completely. That means the numerator and the denominator. So the numerator for the first rational expression can read it backwards. It's just trinomial where a is equal to 1. So I can find the factors of 3 that subtract to get me 2. The answer is 3 and 1. Because it's a negative 2, I'm going to need a negative 3 and a positive 1. The denominator can't factor, so I'm going to leave it 2x plus 1. The numerator for the second fraction is a trinomial, but this time a is greater than 1, which means I'm going to have to use the sum and the products. So my sum would be negative 3, and my product would be 2 times negative 2, which makes it negative 4. So then you're going to find the factors of 4 that subtract to get you 3. The answer would be 4 and 1. So then I need to get a negative 3, so I'm going to have a negative 4 and a positive 1. So then I'm going to have 2x squared minus 4x plus x minus 2. Because now that I have 4 terms, I'm going to factor by grouping. The GCF of these two is a 2x. I'm left with x minus 2. The GCF of these two would be plus 1. I'm left with x minus 2. I'm going to take my GCFs and group them together and then bring down one of the x minus 2's. This is my factored form of my numerator. So I'm going to have 2x plus 1, x minus 2. The denominator can factor by reading backwards. So you're going to find the factors of 5 that subtract to get you 4. It's going to be x and 5, x and 1. I need to have a negative 5 and a positive 1. Because we are multiplying now, I'm going to multiply straight across, which means I'm just going to make this one big fraction. So then I can look to simplify things and cancel things out. The 2x plus 1 and the 2x plus 1 are both opposites, so they can cancel. The x plus 1's can both cancel out, and I'm left with an x minus 3, an x minus 2 on the numerator, over an x minus 5 on the denominator.